Welcome to the session 2 of multi-cylinder applications of chapter 2 module 5 of fluid power engineering. In this I would like to highlight the control diagrams. The figure shows the concept of the control diagrams here for a given valve. Control diagrams are nothing but is a representation or represents the conditions of control elements in relation to the steps or the time, the switching time itself not being considered here. Example for this is control diagram of a 3x2 roller actuated spring return valve that you can observe from the figure. The first figure explains us the activity of a cylinder, that is a valves, how 3x2 valves works here. That is it's a graphical representation. It consists of a square pockets. There are 3 valves, that is 3x2 valve. It can be observed from the control diagrams that the valves opens at step 1, that is between 0 to 1 in the second diagram, and remains open till the step 4 and closes at step 4, that you can observe. There is a flat curve between 0 to 1, then 1 to 0 to 1, between 1 dash you can observe 1 to 1 dash, or you can take like this also, that is 1 to 2, 2 to 3, 3 to 4 it is again flat, then 4 to next step it is step down, and then it is till 5 it is normal functional line. That you can observe, there is a sudden rise and drop of the functional line, indicating that opening and closing of valves instantaneously or instantaneous and not in gradual. Signal overlap. Here there are two important points that we can observe here. One is signal overlap and signal suppression. When it comes to signal overlap, any device, a memory device or a valve may receive signals from both the ends from pilot valves, that is at the either at the starting at the ending. The signals will be applied simultaneously sometimes, or there may be a situation where signals are fed to both the ends of the valves at the time, or signals already exist on one end and another signal is applied at the other end without removing the signal already applied at the other end. Such situations are known as signal overlapping. Signal overlap is a very common recurring problem in most of the control engineering problems. For example, in a coordinated motion, the 5x2 memory valve, the valve can switch positions only when a single pilot signal is present. You can observe from the figure that is signal overlap in memory device, that is 5x2 valve. You can observe there is a cylinder consists of a piston and the piston rod. There is a valve, that is 5x2 valve. You can observe there are pilot signal and the valve here. The two signals are active on 5x2 valve simultaneously, that is shown in the arrows. Then such a situation is called signal overlap. In pneumatics, there are various possibilities for eliminating the unwanted signals. One must distinguish between the two main groups of signal overlaps. That, as I told, say the step 1, that is the signal which is still applied in overridden by a stronger signal called signal suppression. As I have explained, as I have mentioned earlier, the applied signal is cut out, that is signal cut out, or it can be eliminated. The signal suppression, in this case, the signal which is still applied is overridden by a stronger signal. The figure, that is methods, the various methods that we are using for signal suppression. One such method is that using differential pressure operation and using bistable valve with regulation. Figure 1 shows using differential pressure operation which contains a directional control valve with different differential pressures or pressure operation, or by means of a bistable valve with a regulator or one of the control sides. Signals 1 to 2 is overridden by signal 1 to 4. In terms of function, both methods are equally good. However, ensure reliability of operation, it is necessary in the case of differential pressure operation that both the signals, that is 1 to 2 and 1 to 4, have the same pressure level. For a chosen pressure difference in the case of using bistable valve, the difference in pressure between the signal 1 to 2 and 1 to 4 must be sufficient magnitude. That is differential pressure method, that is signal suppression operating under differential pressure condition, or using bistable valve with regulation condition. Both the conditions or both the methods are equally good, but the reliability comes into, when the reliability comes into picture, it is necessary in case of differential pressure operation, that is both the signals, that is 1 to 2 and 1 to 4, have the same pressure for a chosen pressure difference. Signal elimination methods or technique. It is possible to eliminate signal either mechanically or by means of suitable circuitry. One such is mechanical method. In the mechanical method, we can go for either short impulse transmitter method or idle return roller. In the short impulse method, the directional control valve with over center function and the respective type of control. When using such a type of valve, one should have to follow the points in mind, keep some of the points in mind. That is, the operating reliability depends to a greater extent on the speed of actuation, that is a maximum of 0.1 to 0.15. The diagram idle return roller can observe from the figure. Here the valve is actuated in the middle part of the stroke and not on the ends. That is, the actuator must be operated as far from the stop. However, a continuous signal will exist. Idle return roller can be used if the signal to be eliminated is provided by a limit switches. The use of roller lever valves with idle return to eliminate signal overlapping has its own disadvantages. The one such disadvantage is that the end position cannot be sensed accurately because it is actuated, the valve is actuated in the middle part of the stroke but not at the ends. So it may not sense the end positions. Functions may be impaired due to contaminations because there may be a chance, since it will not sense the end positions, there may be a chances of entering the contaminant. So it may not it may not sense it. Fast control of the system are not possible. Coordinated sequential motion of two cylinders. So here you can observe from the figure. For example, let us take the coordination motion of the two cylinder. The sequence of motion of the cylinders being as follows. Say in the step 1, the cylinder 1A, from the figure 1 you can observe the cylinder 1A extends, whereas in the step 2, cylinder 2A extends. The step 3, cylinder 1A retracts, and in the step 4, cylinder 2A retracts. The step 5, that is what the initial positions on either conditions, you can observe from the figures here. Yeah, you can observe here, that is between 0 to 1, it's a flat curve. From 1 to 0, that is 1 1, it is a sudden steep, that is steep rise in the curve, that is when the cylinder 1 and 2 are extends, and it will be continued till 1 to 4, and from 4 there is a sudden drop, and up to 5 it is totally flat. Signal overlap occurs in steps 1 and 3. In the initial position, signal is applied at the control port of the double pilot valve V1 via actuated limit switch 2S1. And now, if the push button, say of 1S1 is actuated, a signal is applied at the control port 1 to 4 of the double pilot valve V1. Here the signal is a signal at 1 to 2 and 1 to 4 overlaps. That you can observe from the figure. That is how it overlaps between 1 to 2, and that is in the figure 1. You can observe the valve 1 of P, and that is 1 to 2, it is overlaps. Again, when it comes to figure 2, that is during retraction, it is overlaps. Similarly, a signal overlap occurs at the double pilot valve V1, that is the extension of the cylinder 1A actuates the limit switch 1S3. The cylinder 2A extends and actuates the limit 2S2, which triggers the signal for the immediate retracting of the cylinder. If the limit switches 1S3 is still switched at this point, two signals are applied simultaneously at the double pilot valve V1, and the valve cannot switch over. In the circuit diagram, an arrows shown at cylinder 1A and 2A at the limit switches 2S1 and 1S3. The direction of the arrow indicates in which the direction over travel of the roller lever valve with idle return leads to actuation, and there will be no actuation taking place in case of over travel in the opposite direction. It can also be eliminated by use of lever valves with idle return as limit switches. The valves are actuated in one direction of the movement only by the position rod and are configured in such a way that actuation is triggered just shortly before reaching the respective initial and end positions. signal can be eliminated by reversing the valves also. The signal elimination by means of a reversing valve is a frequently used solution. The principle in this case is to allow the signal to be active only for the required length of time. This can be achieved by blocking the signal downstream of the signal element by means of a reversing valve or by supplying energy to the signal element only when the signal is required. A double pilot valve is used to effect the reversal. The next content in this topic is methods of pneumatic circuit design. Many pneumatic circuits have been designed by trial and error method, but more methodological approach incorporating various safety and other functional aspects would repeat better benefits. The pneumatic circuits can be designed by various methods. Some of the methods mentioned here are initiative design based on knowledge of elements, initiative design based on logics, use of Karnoff, vertical diagram, program generators, etc., cascade method and other methods. One such method as per syllabus point of view, a reversing valve is used to eliminate signal overlap, that is in the cascade method. It is observed to remove, it is that is illustration of signal elimination by reversing valves using cascading method. In this, a reversing valve is used to eliminate signal overlap. It is desired to remove signals at the 5/2 double solenoid pilot operated valve, say at 1 to V and 2 V is in correct time in order to eliminate signal overlap. To achieve this, the pressure supply lines of limit switches 2S1 and 1S3 must be exhausted quickly before the control signal is applied. That is, there is no opposition in the existence of signals at the memory valve V1 and V2. The cascading method of one of the cascading method that you can observe from the figure, that is there are two cylinders here again, 1A and 2A, that is limit switches 1S2, 2S1 and 1S3. You can observe that is arranging cylinders in series, that is nothing but cascading method. Through a number of pneumatic circuits are designed by trial and error method or intuitive method. Many prefers methodological approach because trial and error method may not give the accurate results, and also here we are not going to we are just based on the trials that we can plot the results which may not be accurate. So many prefer methodological approach, of which the cascade method is found to the simplest and easiest one, where signal elimination is affected by use of reversing valves. In this method, the supply of air to a various pilot trip valves which has been derived from a group of selector valves, which ensures air supply to the pilot trip valve only when needed, and at all the other times the trip valves are without air supply. The sequence of operations that you can observe, that is in the initial position, both the cylinders are in the retracted position and the valves 1S2 and 2S1 are actuated, and OV is reversing. OV is reversing valve, supplies the line say P, and P with compressed air or exhaust, these two atmosphere. In the initial position, both the cylinders are retracted and the valves 2S1 and 1S2 are actuated, and pressure is applied to control ports 1 to 2 of the 5/2 double acting pilot operated valves V1 and V2. Cylinders indicates cylinder 1A valves and 2 cylinders 2A valves. When the push button is used to depress the reversing valves, OV is actuated, that is switches has been actuated. The line P1 is supplied with compressed air and line P2 is exhausted. The limit switches 2S1 is actuated. The control ports 1 to 2 of the valve 1V and is unsuppressed. Pressure is applied to port 1A and 1V, and the valve actuates or it reverses. The cylinders 1A extends and the limit switches 1S2 is deactivated, or nothing but it can be reset, and the control port 1A of the reversing valve OV is exhausted. At the end of the extension of the cylinder 1A, the limit switches 1S3 is actuated and the valve 2V reverses. The cylinder 2A extends and the limit switcher 2S1 is reset at the end of the extension of cylinder 2A. The limit switches 2S2 is actuated and the reversing valves are pressure line 2 is supplied with compressed air and the pressure line 1 is unsuppressed. The valve 2V switches and the cylinders 2A retracts. That you can observe from the figure. That is 1A and 2A are the two cylinders. Initially it will be in the retracted position, and the cylinder 2A extends and the limit switch 2S1 is reset. When the cylinder 1A is extended, the limit switches 1S3 is actuated and the valve 2V is reverses. During the end of the retraction stroke or retraction of the cylinder 2A, that is the second cylinder, the limit switch 2S2 is actuated, the valve V1 is switched and the cylinder 1A is retracted. At the end of the retraction of cylinder 1A, the limit switch 1S2 is actuated and the system is once again in the initial state. That is, a new cycle can be started started by depress. That is push button 1S1, operating push button 1S1. When it comes to certain merits of cascading method of pneumatic circuit diagram is, of course, the designing, drawing and checking of circuits are more easier and faster in case of cascading method. Fault diagnosis is easier. In turn, the troubleshooting. The required task in each cylinder and their signal elements are fully ensured. When it comes to limitations, so it has certain limitations also. So lengthy work, of course,